Today we're going to be talking about the mean of geometric distribution. The mean is calculated as the expected value of x, and one way to calculate this is just with the summation from x equals 0 to infinity, and I apologize, the value starts at 1, of x times p of x. Okay, and we know what the probability distribution is here. It's geometric, so this is going to be 1 minus p to the x minus 1 times p. It turns out that determining this sum, it's not that easy. It's not hard, but it would involve some tricks from calculus. Okay, so there's an easier method that we talked about. The expected value of x is nothing more than the derivative of the moment generating function of a geometric evaluated at 0. So we're going to just calculate the derivative of the moment generating function for a geometric distribution. And it's p times e to the t divided by 1 minus q times e to the t. Okay. So if we want to calculate the derivative here, we're going to have to use the quotient rule. Okay, and when we use the quotient rule, okay, we're going to differentiate the top. The derivative of the top is itself. We're going to multiply by the bottom. Okay, we're going to square the bottom. Then we're going to subtract the top. Now, when we subtract the top, we're going to leave the numerator alone, so that'll be p e to the t, times by the derivative of the denominator. The derivative of the bottom is minus q times e to the t. Okay, so we'll need to FOIL and simplify this. Okay, when we FOIL, we'll have to distribute these terms, right? So I'll be left with p e to the t minus q times p e to the t plus p q e to the t, and that will be e to the 2t divided by 1 minus q times e to the t squared. Okay, great. Well, this is the derivative. The next thing I'm going to do is I'm going to evaluate this derivative with t equal to 0. And I'm going to just note e to the 0 is 1. So wherever I see e to the 0, I'm going to replace it by 1. Minus q times p times 1 plus p times q times 1 divided by 1 minus q times by 1 squared. Okay, well that's fantastic. We should notice these two things cancel, and I'm just left with p divided by 1 minus q squared. And one more important thing to note is that q is defined as 1 minus p. So if I use that, that means that this is going to be p, and I'm going to solve for q here. I'm going to substitute that it's 1 minus p, so I'm going to get 1 minus p quantity squared. This will be p over p squared, and that gives me 1 over p. Okay, that means that this is the mean, it's the expected value, and I'm just going to go back up here to the top. This will be equal to 1 over p. Okay, so the mean of a geometric distribution is 1 over p. One other thing that I'm just going to tell you, if you wanted to calculate the variance of a geometric distribution, is going to be e of x squared minus the mean squared. And of course, the mean here is 1 over p. If you were to do that, what you're going to get for the variance is q over p squared. Of course, this piece, that is 1 over p squared. And I'll give you a hint how you'd calculate this. You'd use that it's the second derivative of the moment generating function evaluated at 0. So you'd have to go back up here to the derivative of the moment generating function and take the second derivative of that, then evaluate it at 0. I'll then do a bunch of algebra, and you'll arrive at the variance as q over p squared.